So a lot of you, and by a lot of you I mean that one friend, you know who you are, has complained that my background looks distracting. So here you go, a hopefully better background which I most definitely did not spend 10 minutes walking around the house trying to find. Yeah, things did not go according to plan. I made 2 extra videos before this planned video, but not like all of those videos are over, and after spending 2 weeks not doing anything because of school and laziness, the most important thing is laziness. Let's start off the first proper and actually planned video here at the Celestial. Let's cover our whole Earth. Unless you're not from here or it's the far future where we have colonized the moon and Mars, in which case let's cover my homeworld. The Earth is 4.5 billion years old. It has an aphelion of 152 million kilometers and a perihelion of 147 million kilometers from the Sun. Its semi-major axis is at 149 million kilometers from the Sun, with an orbital period of 365 days, or a year, with a day being 24 hours. Its mean radius is 6,371 kilometers with an equatorial circumference of 40,075 kilometers. This is the part where you guys might skip ahead, so here's a picture of a kitty, so that you don't go. It has an internal volume of 1 trillion cubic kilometers, a mass of 5.97 quadrillion kilograms, a surface gravity of 9.79 meters per second squared, a mean density of 5.514 grams per cubic centimeter, making it the densest planet in the solar system. It has an axial tilt of 23.4 degrees, a mean temperature of 14.9 degrees Celsius, a surface pressure of 1014 millibars, with its atmosphere comprised of 78% nitrogen, 21% oxygen, 0.9% argon, and 0.04% carbon dioxide, with the rest comprised of other gases. It has a moon, 5 quasi-satellites or quasi-moons, more than 1,800 artificial satellites, and more than 16,000 trackable space debris, with potentially trillions more which are untrackable. Its population is at 7.7 billion. So we know the Earth tilts to give us seasons at 23.4 degrees in fact, as I said earlier, and at the solstice is at its furthest tilt. That's cool and all, but Earth's tilt was not always this way. Earth's tilt varies from 22.1 to 24.5 degrees every 40,000 years in a cycle. So we all know a day is 24 hours. Or is it? Well, it depends on what you define as a day. If you use solar day as a measurement of a day, where a day is defined as the amount of time from where the sun was last at a position in the sky to the next time it does that, then it is 24 hours. But if you use stellar day, where it's the same thing as solar day but instead of using the sun use a fixed star, then it's 23 hours, 56 minutes and 4 seconds. Now for the orbit. Don't you dare exit this video. We know the Earth orbits the Sun once a year, or 365.25 days, and as anyone older than the age of 4 can tell you, we have a leap year once every 4 years because humans love to complicate things. Like all things that orbit, Earth's orbit is not a perfect circle but more of an ovoid. So at times it gets closer and at times it gets further, which is what astronomers call aphelion and perihelion, as I said earlier. Earth's orbit is not static, it orbits at times almost circular and at times more elliptical, in a cycle of 100,000 years. Earth's orbit around the Sun is not entirely along on a flat plane either, it tilts a little, but that's not important. Moving away from the Earth, we have Earth satellites, both natural and artificial ones. We have our satellites, 2 space stations, and too many space debris, the obvious moon, but we also have 5 quasi-moons, as I said earlier. In the easiest way I can put it for now, it is a celestial object that stays close to another celestial object, in this case the Earth, but does not quite orbit it. Like all planets, the Earth is not actually a sphere. But it isn't flat either, I'm looking at you flat earthers. But it is actually a shape resembling an oblate spheroid, with the poles flatter and the equator bulging out. However, that isn't accurate either, as the Earth is not entirely smooth. Like all planets, Earth's interior is layered. Unless you subscribe to the theory that the Earth is a hollow sphere, the outer layer is the crust, which is the outside part of the Earth that we live on, with all the wonderful things we see like oceans, mountains, canyons, plains, pollutions that we made, etc. It is divided into tectonic plates, which are enormous slabs of rock that floats on the mantle. The plates move, although really slowly, like 3 centimeters a year slowly, due to the convection currents generated in the mantle. causing the mantle material to pull on the plates. The plates can subduct, collide, form new material and break, creating mountains, valleys, trenches and earthquakes. And that's basically all that my school has taught me on physical geography that I can actually use for this video. On the crust is all the wonderful surface features like oceans, which cover 70.8% of the Earth's surface. Beneath the waves are underwater trenches, plains, volcanoes, etc. Also, 97.5% of the Earth's water is saline, the rest is fresh water. But you already knew that because all of the safe water can basically shoving it in your face. The remaining 29.2% is land, which is covered in deserts, plains, mountains, cities, etc., all with different climates and everything. Also on the crust is the highest point, Mount Everest. The tallest mountain, Mount Kea, which measured from the base is higher than Everest, and Chimborazo, furthest point from the Earth's center due to it being at the equator and that the Earth bulges out there. And there's Challenger Deep, lowest point on Earth. Just after me looking at my GPA at the end of the year. Beneath the crust is the mantle, which is not really liquid, which is what 6-year-old Daryl used to think, but it's solid-ish. I use the word ish because the mantle is more like a really viscous liquid made of molten rock, so it just flows really slowly. Beneath the mantle is the outer and inner core, with the outer core being made of liquid iron and nickel, while the inner core is solid and made of iron and nickel as well. The outer core generates the magnetic field that surrounds the Earth, as it's made of molten iron alloys that moves, forming a geodynamo. One thing you might already know is that the deeper you get, the hotter it gets, like crazy hot, like 5,430 degrees Celsius at the core hot. But why? Earth's heat comes from 20% leftover heat from when the planet formed from colliding protoplanets. I've mentioned how planets form in my previous video, hint 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 hint. While the remaining 80% is from radioactive decay from uranium, thorium and potassium. Surrounding the Earth is its atmosphere, which is also divided into layers. You guys know that the higher you go, the thinner the air is, so technically our atmosphere doesn't just end anywhere. It just gets thinner and thinner until it fits into space. Just like my GPA, after I decided to work on this video for 2 days instead of doing my homework and my projects. The layer we live in, the troposphere, is the lowest and the thickest, with enough oxygen concentration for us to live. As most of the atmosphere's water vapor is here, most of weather happens in this layer. Apparently, the height at which the troposphere ends, aka the tropopause, is not constant, as it varies from 8 kilometers at the equator, like here in Singapore, to 17 kilometers at the poles, although weathers and seasons affect it as well. Above the troposphere and the tropopause is the stratosphere, starting at 20 kilometers at the equator and 7 kilometers at the poles. The weird thing is, unlike at the troposphere, where the higher you go, it gets colder as the air is less dense, here at the stratosphere, it gets warmer the higher you go, due to UV absorption by the ozone layer, although temperatures are still usually below freezing. Planes usually fly here as the air is less dense, so it makes them more efficient. Starting at 50 kilometers and ending at 85 kilometers is the mesosphere. At the bottom part of the mesosphere is the stratopause, where temperatures start to drop again, and it's the coldest place on Earth, with temperatures below negative 85 degrees Celsius. It is so high up that only sounding rockets and some balloons can access it, but it is too low for satellites to explore, as it is also where they start to burn up and disintegrate along with meteors. Now here is the really weird part about our atmosphere. Although the official start of space is 100 kilometers at the Kármán line, there is still some atmosphere beyond that point, which is why satellites start to slowly fall back down to Earth as they collide with atmospheric particles. So although technically in space there is still atmosphere here in an area called the thermosphere. Extending from 80 kilometers to 550 kilometers, spacecraft orbit the Earth here like the ISS. Due to solar radiation, it gets hotter here the higher you go up, which can get up to 25,000 degrees Celsius, but because the air is so non-existent, it will still be cold here. Due to radiation, radio waves can bounce back to the Earth when they are aimed at this layer. Also, auroras sometimes form here. Now, the final part of our atmosphere, the exosphere. From 600 kilometers to 10,000 kilometers above the Earth's surface, atoms here just escape, never to come back again. So we all know Earth has life and whatnot, I'm here for a reason. With life potentially forming 4.28 billion years ago, which is really cool if you consider the fact that the Earth is only 4.5 billion years old, which means that life formed really quickly after its formation. Well, we all know life is basically everywhere, from the mountains to the trenches to your pillow to raindrops and all. Unfortunately, this channel is about space and not biology, so I won't go into too much detail about life. So here's some random facts just so I can, give the video some more filler. 99% of all species are extinct. We have catalogued about 1.74 million species, but 80% of species might be undiscovered, or we might have accidentally killed them without us knowing. And the weight of all living creatures, called biomass, is around 4 trillion tons of carbon. And we are also causing the 6th mass extinction due to human hunting, activities and pollution. The history of the Earth. A section so long and daunting that I didn't bother to write or research anything about it for 2 weeks just because I was that lazy. But now that I'm in my reproductive state, I'm going to talk about it because I can. Most people, and by most people I mean paleontologists, use eons and eras to describe Earth's history. But this is a space channel and not a history or paleontology channel, which is only going to cover Earth this one time and never gonna cover it again for a few years. So I'll only use eons but not eras. So let's go. Please don't fall asleep or skip ahead. 4.5 billion years ago, there was a nebula. One day a supernova happened nearby and caused the nebula to collapse, forming a protoplanetary disk. Blah blah blah, the sun formed, blah blah blah, the disk around it started to form protoplanets which collided to form planets. And bing bang boom, no pun intended, the Earth formed, one of the few survivors of the era. The Hadean era has started and the Earth's crust has solidified and the interior differentiated and whatever. Then one day a protoplanet called Theia hit the Earth and the debris formed the ring which formed the moon, which was crazy close to the Earth before it drifted away. Also the impact changed our rotation speed, which the newly formed moon slowed down until we have 24 hours today. 4.1 billion years ago, the late heavy bombardment happened, causing asteroids to hit the Earth. Like my lecturers throwing projects at my face, I've got 6 of them. The main theory is that the orbits of the gas giants changed, causing waves of asteroids to fly into the inner solar system. Sounds like fun. Life might have already formed at this point, which I won't go into details as I'm not a biologist, and theories range from came from space to formed from non-living organic things and survived the asteroid impacts by hiding in vents or something. There might have already been oceans which might have covered most of the Earth's surface, which formed when the Earth started to cool, forming clouds and rain. By the Archean eon 4 billion years ago, the first proto-continents have formed. And from 4 billion years ago all the way until 600 million years ago, not much really happened for life. Not much as in everyone was still a single-cell organism for all that time. Around 3 billion years ago, cyanobacteria evolved to photosynthesize, which I'm assuming you guys know what it is if you've ever learned that in science, forming a lot of oxygen in the event called the Great Oxidation Event, as the atmosphere started to be filled with oxygen. The oxygen was toxic to the microorganisms that did not use it and they began to die off. All the oxygen began to react to the greenhouse gases, keeping the Earth warm, causing the world to freeze over, which is now called Snowball Earth. This last part happened in the Proterozoic eon. I definitely butchered that. One thing I did not touch on is something called the supercontinent cycle. Not really important, but kinda cool. You all know about Pangaea, but did you know that there were more supercontinents before Pangaea? During this time period, the supercontinent there was called Rodinia. Around 600 million years ago, now in the eon we are in, the Phanerozoic eon, the last snowball Earth melted away. Yes, there's like more than one of them, and suddenly there was a huge explosion in the diversity of life called the Cambrian explosion, with all sorts of new creatures like worms, jellyfish and trilobites. Around this time, the ozone layer has formed and land was no longer baked by UV radiation. Life finally began to move on to land, first plants and then animals. Now this is the part where I will immediately gloss over all of the evolutionary things that happened during this time because this video is already long enough. Suffice it to say, life went on land, diversified, a lot went extinct 5 different times, ranging from the worst, called the Great Dying 252 million years ago, which killed off 90% of all species. Take that, Thanos. But also created the dinosaurs, to the KT extinction with the asteroid and killing the dinos and everything, but also led to the rise of mammals, to the one you are now living in, caused by humans. Now speaking of humans, the world's deadliest animal. So deadly we can't even trust ourselves and we go on to declare wars, civil wars, riots, all the bad things, murders, homicides, whatever, I can't tell the difference. Marvelous creatures we are. Although I do not intend to dive deep into our evolution and early history, it is important to note that there's actually more than one human species. We have found fossils from 15 species of humans, but we are the only ones left. As we all know, humans evolved from chimps and we came from Africa.
Unless you don't believe in evolution, in which case all of the following things is thrown out the window.
Our species of human, Homo sapiens, has only been around for 300,000 years, which means there was a time of overlap with other human species, with interbreeding and such.
And probably wars to IDK.
Humans have basically spread to all over the globe with the help of the ice ages causing sea levels to drop, allowing humans to cross into North America. Now on to civilization. Civilization basically started because of farming. Farming meant people lived in a fixed location and not everyone needed to be a farmer, so language developed, religions, culture, etc. All of this was called the Neolithic Revolution. Technology developed, although quite slowly. Nations formed, city-states formed, wars were started, all that good stuff. One thing led to another, and the scientific and industrial revolutions changed the world. Climate change started, globalization started, technology basically exploded, not literally. And well, more wars here and there, nukes, space travel, the internet, memes, unholy amounts of memes, just so many memes, Avengers Endgame, and here we are today.
There, I summed up all of human history. It's pretty impressive actually, given the fact that all of our history happened within 10,000 years only, and our modern life is only a few centuries old. Makes one wonder about the future, and speaking of the future, yes, this channel also covers sci-fi, but only because I need filler and padding for videos, and also because I need more filler and padding for videos in the future when I cover about stars. In sci-fi, Earth has been portrayed in many different ways.
From being a utopia like in Star Trek, to being nuked to a literal hell in Fallout, to not being there at all in Star Wars, to being invaded by aliens and everything from War of the Worlds to Independence Day. Then there is fiction where the Earth is destroyed in some episodes of Star Trek to Hitchhiker's Guide to the Galaxy. In more grounded sci-fi like The Expanse, it's run by the UN, but most of the population is jobless due to automation, a future which I believe is gonna happen. Well, in Battlestar Galactica, Earth is a myth that was found, although kinda controversially depending on who you ask. Because we are from Earth, some sci-fi portrays Earth as the center of government for numerous interstellar nations, from the United Federation of Planets in Star Trek to the Imperium of Man in Warhammer 40k.
Whether or not this Earth-centric view becomes a problem in the future remains to be seen. And there you have it. Everything about Earth badly summed up in a video that is also the most ambitious and longest and difficult one I've ever done. The next video will be about moons, but at this pace I expect it like next month or something. And also because you should not trust me as a source of information, it's best you guys research on your own if you want to know more.